We're going to continue looking at measures of position. So far we've gone through z-score and percentile. Remember that z-score was just a measure of how many standard deviations a certain data piece is away from the mean. Okay, it's not its actual score. It's just basically telling you where, according to all the other data, does that single piece lie. Percentile does the same thing, except where z-score uses standard deviations as kind of your scale. Percentile uses scales. It breaks it into 100 separate groups, and it tells you what group would you fall into. Okay, so if you fall into the 80th percentile, that means 80% of the data is less than you, and 20% of the data is more than you. We're going to extend that a little bit further. One of those is decile. Deciles breaks it into 10 equal groups. So instead of having 100 equal groups, we now have 10 equal groups. Deciles aren't used that often. We want you to know that they're out there, but again, that's just something that's not used very frequently. Quartiles, however, are specifically for box and whisker plot, which we'll get to next week. We'll be looking at them. For quartiles, think 4 separate groups, right? So how many different, let's say we're cutting a piece of rope into 4 parts. How many cuts would you have to make? Well, you cut it in half. Now you have 2 halves, and you would cut each one of those halves in half. Now you have 4 pieces, so you made 3 cuts in order to get 4 pieces. Same concept here. We have to find 3 numbers in order to separate the group into 4 equal parts. Those 3 pieces are quartile 1, quartile 2, and quartile 3. Okay? What you do to find each one of them is you find the median. Remember, median is middle number of these different ranges. And I'll explain those a bit more in a second. Occasionally we use something called the interquartile range. The interquartile range is found by taking quartile 3 minus quartile 1. Okay? That will be used a little bit later on. So here we go. We're just going to jump right into how do you find quartiles. Okay. Here's your data. We have 8 numbers. First thing is to put them in ascending order, lowest to highest. Okay, there they are. First thing we're going to find is quartile 2. It's usually the best place to start. It's actually the best place to start. The way that you find quartile 2 is you take the median of all the numbers, starting at low and going up to high. So, if you remember how to find median, we count how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them. So you take 8, add 1, divide it by 2. 8 plus 1 is 9. 9 divided by 2 is 4.5. So this means this is not our quartile 2. This is the number that will be our quartile 2, the 4.5 number. 1, 2, 3, 4. Half is right here. What number do you use? Remember, you take these 2 and find the average. So 13 plus 15 is 28. 28 divided by 2 gives us 14. Now that we have our quartile 2, we use that to find quartile 1 and quartile 3. What you want to do now is not include the median and break it into 2 separate groups. Okay, so there's 14 in here that we're not using. Okay, now you find the median of the low up to the median, but not including the median. And then for quartile 3, you will find the median of the original median up to the high, but not including the median. So here we go. This group right here has 4 numbers in it. So we got 4 plus 1 divided by 2. That's 5 divided by 2 is 2.5. The 2.5 number, 1, 2, is right there. We average these 2. 6 plus 12 is 18. 18 divided by 2 is 9. That's our quartile 1. Quartile 3, same concept. 4 numbers. 4 plus 1 divided by 2. I can do it down here. We don't have to, but is 2.5. So the 2.5 number of just this group, 1, 2.5. 18 plus 22 is 40. 40 divided by 2 is 20. So there's your quartile 1, quartile 2, quartile 3, 9, 14, and 20. Okay. All right, what if you have an odd number of pieces of data? And I'm going to show you an example. So it's the same numbers, I just added the number 28 in here. Okay. First thing you do is you find the median. Remember, your median is, how many numbers are there? There are 9 numbers plus 1. 9 plus 1 is 10, divided by 2 is 5. So it's the fifth number, 1, 2, 3, 4, 5. So it's actually a number that's part of our data set, 15. Then, again, we break this into 2 groups, but we don't include the median. And now you find the median of this first group. How many numbers are there? 1, 2, 3, 4. 4 plus 1 is 5. 5 divided by 2 is 2.5. 1, 2.5. Find the average of those 2 numbers. 6 plus 12 is 18. 18 divided by 2 is 9. Then for quartile 3, find the median of these numbers. There are 1, 2, 3, 4. 4 plus 1 is 5. 5 divided by 2 is 2.5. 1, 2, 2.5. The average of 22 and 28 is 25. Okay, so there's quartile 1, quartile 2, quartile 3. Again, if you had troubles with that, rewind it, go through it again. If you still have questions after watching it 2 or 3 times, please write the question down and talk to me tomorrow. I'm going to show you one more example with 11 pieces of data, because something different happens there. And I'm going to show you another way of finding quartile 1, quartile 2, and quartile 3. It's basically the same thing, it's just the numbering system is a little bit different. Okay? You pick which one you like better. So the first part is the same. To find quartile 2, you find the median of all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 numbers. Now, what I'm thinking of this as, I'm thinking of all of these numbers as being numbered 1, 2, 3, 4, 5, and so on up to 11. So, what is the median of my first number and my 11th number? Well, I add those up, divide by 2. 11 plus 1 is 12. 12 divided by 2 is 6. So it's my 6th number. 1, 2, 3, 4, 5, 6, 18. Okay, that's very similar to what we've done before. Difference is, I'm not going to break this up into its own group. The way I'm going to look at it is, what is my low number? It's the first. What is the median? The median is 6, but remember, we do not use the median, so this is the 5th number. I find the average of those. 6 divided by 2 is 3. So the 3rd number is my median. 1, 2, 3, that's 12. 12 is now quartile 1. Same concept for quartile 3. We use our median as the low, except remember we don't actually use the median. So the median was the 6th number, 1, 2, 3, 4, 5, 6. So I'm going to start with my 7th, and my high will be my 11th number right there. 7 plus 11 is 18. 18 divided by 2 is 9. So my 9th number, 1, 2, 3, 4, 5, 6, 7, 8, 9. 33 is my quartile 3. Same concept as before, it's just you go about it a little different. You do whichever one you like. If you like breaking it up into boxes, great. If not, no worries about it. Okay? All right. Last thing for this is an outlier. An outlier is something that's extremely high or extremely low. Okay, when you compare it to the rest of the data. Well, how do you measure what's too high or what's too low? I have a little formula for us. If you take quartile 1 and you minus 1/2 of the inner quartile range, or greater than quartile 1 plus 1.5 of the inner quartile range, that can be considered an outlier. Ta-da! Things just changed. As I said that, I realized that that was wrong. Okay? It is quartile 1 minus 1.5 of your interquartile range. And if you take quartile 3 plus 1.5 of your interquartile range, anything less than or greater than those would be considered an outlier. Okay? I'm going to show you that. We are going to look at, we're going to go back here, and we're going to use these pieces of data. 5, 6, 12, 13, 15, 18, 22, and 50. Okay? 5, 6, 12, 13, 15, 18, 22, and 50. I'm going to forget those numbers. 5, 6, 12, 13, and 15, 18, 22, and 50. Okay, so what is our interquartile range? If you remember, our interquartile range is quartile 3 minus quartile 1. So what was quartile 3 and quartile 1 for these? Back. Quartile 1 was 9, quartile 3 was 20. So we are going to find our IQR, which is quartile 3 minus quartile 1. Okay? Quartile 3 was 20, quartile 1 was 9. Oops. That equals 11. All right? Now what we're going to do is we are going to take quartile 1, which was 9, subtract 1.5 times 11. Okay. 11 times 1.5 is 16.5. So 9 minus 16.5 is negative 7.5. Okay. And then we're going to take quartile 3, which is 20, and add 1.5 of 11. Remember, 1.5 of 11 is 16.5. 20 plus 16.5 is 36.5. Are there any numbers that are less than negative 7.5 or greater than 36.5? There are. That one right there. 50 is greater than 36.5, and therefore we would call 50 an outlier. Okay? Sometimes you have outliers, sometimes you do not. There are no low outliers here. Nothing's less than 7.5. 50 is an outlier that's greater. All right, we will see you tomorrow.